Hello and welcome back to the Pittcon podcast. In this episode, we speak to Matthew Glasscott from the US Army Corps of Engineers about sustainable building materials.
Modeling riverways while the Corps constructed our current portfolio of over 1,000 dams and tens of thousands of miles of canals allowed us to build a lot of experience in things like geotechnical science, environmental science, and coastal and hydraulic science, each of which grew into its own ERDIC laboratory over the past century. And so we've been innovating to make the world a better and safer place since about 1929 towards that end. And I'm proud to work with over 1,000 engineers and scientists at our now 7 laboratories spread all over the United States.
Very nice. And how did your previous research prepare you for the sustainable materials field?
So academia is doing a fantastic job of emphasizing sustainable materials through graduate education, and my experience was no different. I was the first graduate student of my PI, Jeffrey Dick, at the University of North Carolina, Chapel Hill. And while I was there, I got to join the legacy of hundreds of electrochemists who have pushed our understanding of disruptive energy technologies forward. When I got to the Army Corps of Engineers, I realized we've been doing a fantastic job pushing energy technologies forward, decarbonizing the grid, but there was a massive wall that we still had to overcome, and that wall was made of concrete. So I was surprised to learn when I started my journey with the Corps that about 7 to 8% of global anthropogenic CO2 emissions are actually directly related to the manufacture of cement alone. And if you add in the contribution of some of the other construction materials we generally think about, things like asphalt, steel, up to 13% of our total emissions can be isolated to that industrial sector.
And how would you define a sustainable construction material?
Before talking about construction materials specifically, I find it can be helpful to define sustainability. So the UN Brundtland Commission in 1987 defined sustainability as meeting the needs of our present without compromising the ability of future generations to meet their own needs. And so when we talk about sustainable construction materials then, what we're trying to do is build better, safer, stronger buildings now to meet our current needs, while keeping in mind the reduction of CO2 emissions which may impact future generations via climate change.
I see. And why is sustainability so important in construction? Obviously, you talked about the emissions relating to cement, but what are the kind of broader themes as well?
So when people talk about decarbonizing buildings, there's kind of 2 categories of that. There's operational emissions, which come from the actual operation of the building. You can think the Energy Star sticker that you see inside your refrigerator reports on the electricity contributions of that appliance. And so operational emissions remain about steady over the entire life cycle of the building. Now there's a separate category, and that's embodied carbon or embodied emissions. And those are emissions associated with the construction of the building, the actual manufacturing and assembly of the construction materials that go into building up that asset. Embodied emissions are highly concentrated in that construction phase and have been receiving a lot of attention recently because they're notoriously difficult to decarbonize. You know, we can electrify the grid, and that's a straightforward path towards reducing operational emissions. But when we talk about altering industrial processes like the manufacture of concrete, all of a sudden we have a much bigger problem on our hands.
I see. And how has the sustainable construction field changed over time? What are the kind of key trends that you've seen that have developed?
Yeah, so this, like I said, this area has been receiving a lot of attention, and a huge development in sustainable construction materials has been the rollout of these things called environmental product declarations. And these are really fun. They're kind of like environmental nutrition facts, like a list that you might see on the side of a cereal box. But instead of reporting things like protein and carbs, they're reporting kilograms of CO2 emissions, kilograms of chlorofluorocarbon emissions, and all these other factors that we're really interested in when we talk about making materials more sustainable. And so before, we were really shooting in the dark when it came to reducing emissions associated with materials because there was no quantitative measure of what those emissions might be. But now, after the rollout of Executive Order 14057 and the implementation of a federal mandate for EPD reporting, we're going to have the tools we need to start comparing, contrasting different materials, and implementing some of these sustainable solutions.
No, that's really great to hear. And what are the main factors to consider when designing a sustainable construction material?
So according to the Portland Cement Association, if I handed you 1 pound of Portland cement, the CO2 emissions associated with that pound of cement are about equivalent, about 1 pound of CO2 emissions, almost 1 for 1. It's about 0.9. And when you think about it, it doesn't seem like that much, especially when you consider that as you drive your vehicle, an average gas tank, as it's emptied around town, you're emitting about 400 pounds of CO2 into the atmosphere. But now you have to think, if you were to, rise above this entire city, see every single skyscraper, all with concrete foundations underneath, all the bridges, all the sewer systems, all the infrastructure, millions and millions of pounds of concrete. So as we talk about scale, the CO2 emissions associated with these materials at scale is what gives them their outsized impact when we talk about reducing CO2 emissions.
Okay, and kind of thinking more about the different methods that are used to kind of analyse these different materials and analyse cement. What are the drawbacks of current analytical methods and models regarding sustainable construction materials?
So when we talk about construction materials then, because we're operating at the gigaton scale, even a 1% reduction in CO2 or 1% increase in sustainability metrics makes a huge impact. And there's a lot of ways we can get at this. So I mentioned before this 1 for 1 CO2 per pound of cement statistic. If you're going to use things called supplementary cementitious materials and blend those into your highly carbon concentrated cement, you can dramatically reduce the CO2 footprint associated with it. And the Army Corps of Engineers has really been spearheading this effort for the last century. So you might have heard of the Hoover Dam before. That was the first mega project to incorporate an SCM that we call fly ash, which comes from coal-fired power plants, up to concentrations of almost 40% to reduce the CO2 impact associated with that asset and also give us some other favorable properties. Our research program within the Army then is focused on demonstrating a lot of these newer sustainable technologies at scale and in the fields. So we're now leveraging complex blends of SCMs from recycled waste streams like computer manufacturing and steel manufacturing to lower the carbon footprint associated with that carbon-heavy Portland cement component. We're extending the service life of asphalt assets with unique and advanced coatings. You can think fewer potholes, so that road now lasts a longer time, and therefore, over its life cycle, we've reduced its associated CO2 emissions. And we're also trying to do really disruptive things, like take a traditional asset that was constructed of concrete and steel, and instead build it out of next-generation wood products, these things called cross-laminated timbers and glulam. So there's a lot of unique strategies we're trying to bring construction materials into that realm of sustainability.
I see. And is there much interest in biodegradable sustainable materials?
So bio-based construction materials, especially those we can harness the power of biology to manufacture for us, are of great interest to the Engineer Research and Development Center. One of the particular areas we're looking to explore is called synthetic biology, or SynBio. And with SynBio, you have the capacity to leverage specific bacteria or other organisms in order to give you advantages both logistically and in the feedstocks you need to generate a structural material. So, for instance, there are current commercial solutions for concrete that actually, using specifically engineered bacteria, allows you to create a cementitious material at your point of use. All you do is provide the food and dump in the bacteria. And so there's a lot of really unique solutions we're exploring that have that capacity to both be sustainable and provide our soldiers and our citizens advantages for their construction projects.
So how could policymakers persuade the construction industry to invest and to use these sustainable materials?
So from the top levels of the federal government, regulations and policies have been coming down, mandating that the DoD start using sustainable construction materials in our projects. We have several pilot programs that are happening within the Tri-Service that are geared towards lowering carbon emissions with specific buildings. And as we've been doing that, following some of these policy regulations and Executive Order 14057, the DoD Climate Action Plan, and the Army Climate Strategy, we've realized there's a lot of gaps. And so our research program at ERDIC is targeting the specific gaps that I mentioned before, things like how do we bring sustainable materials to the point where a DoD organization would feel comfortable using it in our applications, and how do we change our specifications to reflect that confidence? And our program is working very closely with industry to try to make some of those things a reality.
And is there anything that you're working on right now that you're particularly excited about?
I really enjoy and get really excited every day to work with our really diverse group of engineers and scientists at the Engineer Research and Development Center, because as a very cross-disciplinary, multi-lab organization, we get to take problems that we see in the soldier and civilian sector and find solutions that meet multiple needs across the DoD. So for instance, our Coastal and Hydraulics Laboratory, CHL, is responsible for maintaining navigable waterways. And the way they do that is by dredging out harbors and ports. Millions of pounds of silt and other materials come out of our harbors and ports so ships can navigate them. Our environmental laboratory, which I'm a part of, EL, supports that mission by finding beneficial uses for that dredged material. We build islands out of it. We restore wetlands out of it. We extract valuable raw materials like rare earth elements from it. And so when we talk about sustainable construction materials then, our Geotechnical and Structures Laboratory, GSL, noticed we had all this material and said, what if we could harvest some of that dredged material and add it to concrete as a supplementary cementitious material? So the nexus of all these different laboratories working on what one might consider to be unique individual problems and expanding their scope to look for multiple solutions is what really makes ERDIC a unique place to work, a unique culture of innovation to make the world better and safer.